Hello everyone, welcome to the NIPER multiple choice question series 5. In this video, I am going to explain about previous NIPER questions from medicinal chemistry and organic chemistry, and you will have explanation too. So this is my YouTube channel. If you like the video content, do subscribe and share. Now, see, the first few questions will be related to medicinal chemistry, then I am going to explain about organic chemistry questions. Now, in order to master medicinal chemistry, certain things are required. The first and foremost thing is you need to learn the structures of important drugs. So most of the questions can be solved only by learning structure itself. Learning structure is not blindly learning it. You need to understand what all the heterocyclic rings are there, what are the major functional groups are there. If you learn smartly, answering medicinal chemistry questions will become very easier. The reason is majority of the questions are based on only structure. Let us analyze the questions. Okay. The precursors for Penicillin G biosynthesis during fermentation processes. What is that? In order to answer this kind of questions, we need to know the structure of Penicillin G. Let me write about that one. See, all these penicillins, the major thing with them is they have pharmacophore as beta-lactam ring. Beta-lactam ring is this one. Sorry. Yeah, beta-lactam ring has got this pharmacophore. Now let us understand this one. See, this ring is known as, see, all the penicillins has got this ring. So this ring is known as beta-lactam. Now let us understand what you mean by lactams are. Lactams are cyclic amides. CONH is amide bond. When it is cyclized, it is called as beta-lactam. Now look at them. The carbon adjacent to carbonyl function group is known as alpha. The next one is beta. The reason why they are called as beta-lactam is there are alpha and beta carbons. Lactam means cyclic amide. So this ring is known as beta-lactam, and this is a pharmacophore. Now in addition to that, it has got another heterocyclic ring. That heterocyclic ring, sulfur containing with nitrogen 5-membered ring, is a derivative of thiazole. Azole means 5-membered nitrogen containing ring. Thia means sulfur is there. So this particular structure in penicillins is known as 6-amino penicillinic acid. 6-amino penicillinic acid. Now you need to understand the numbering too. Why it is called as 6? The numbering starts from here: 1, 2, 3, 4, 5. And this is 6. At 6th position amine group is there, hence it is known as 6-amino penicillinic acid. Now let us see what is penicillin G. Penicillin G is also known as benzyl penicillin. Now why it is known as benzyl penicillin is, so this is what is the structure of penicillin G is. So along with 6-amino penicillinic acid, it has got this side chain. What is this side chain? When you see this, this is a derivative of phenyl acetic acid. See, this is a phenyl group and this part is acetic acid group. So when you combine phenyl acetic acid with 6-amino penicillinic acid, you will get penicillin G. So what could be the biosynthesis precursor? One is 6-amino penicillinic acid, the other one is phenyl acetic acid. So the option A is correct one. See, the entire question is based on the structure. When you understand the structure, you will get it. Now again, see, one more option is there, phenoxyacetic acid. If you remember, there is one more penicillin which is known as penicillin V. This is phenoxy 6-amino penicillinic acid. Like this one is known as benzyl penicillin. Penicillin V is known as phenoxy penicillin. So it has got phenoxyacetic acid group. But penicillin G has got phenyl acetic acid group. So when you understand this structure, when you know what all the things are there inside, you can easily write answers. So learn structures in this way. You need to identify what all the heterocyclics are there. You need to identify what all the side chains are there. Now, not only this, you need to learn certain other things too. Let me explain about this. See, the 6-amino penicillinic acid has got 2 amino acids. You need to learn that too also. Look at this. Now look at this. If you separate this part is valine. Whereas the other part, the remaining this part, the remaining part, this part is cysteine, sulfur containing one. So it has got a cysteine amino acid, it has got valine amino acid. So it is made up of 2 amino acids. Remember this 6-amino penicillinic acid is a valine cysteine. A valine is there, cysteine is also there. So whenever you learn structures, learn all these small subtle things. Moving to the next one. Now isoniazid is. Now isoniazid, when you see the structure, it is an isonicotinic acid hydrazine. Isonicotic acid hydrazide. Now normally the nicotinic acid structure is this one. So this is an isomer of nicotinic acid, hence it is known as, nicotinic acid is this one, COOH. So INH is a derivative of isonicotinic acid. And isonicotinic acid, it has got this hydrazine group, so it is known as hydrazide. So hydrazide, but this is isonicotinic acid hydrazine. So that is what is the structure of isoniazid is. Okay, moving to the next one. Now, which heterocyclic ring is present in hydralazine? See, hydralazine is an antihypertensive drug. Again, see, all these questions are based on structure. So when you understand the structure and rings, then you will be able to answer these questions. Now, this is what is hydralazine. Hydralazine is an antihypertensive drug. Now, when you see this, the ring, see, chemically it is known as 1-hydrazino. That means at first position you have hydrazine group is there, and the ring is thalazine. So it has got this ring known as thalazine. Thalazine is nothing but benzo. It is a fused ring system. It is made up of benzopyridazine. Benzopyridazine. Now pyridazine is a 6-membered ring with nitrogens in 1,2 position. So this is what is the structure. So which heterocyclic means it has got a thalazine. But let us see what is quinaxalin is. Now quinaxalin is also a fused ring system. It has got a benzo and it is made up of pyrazine. Pyrazine is 2 nitrogens present in 1,4 position. So this is benzopyrazine. So this is there. Now let us see the other one. Quinazolin. Now quinazolin is also a fused ring system. It is also contains a benzo, but it is combined with pyrimidine. In pyrimidine, the 2 nitrogens are present in 1,3 positions. So this is benzopyrimidine, whereas this one is benzopyrazine. Pteridine is a completely different ring. It is made up of 2 heterocyclic rings. This one is pyrimidine, the other one is pyrazine. So a fused system of pyrimidine is pyrazine is nothing but pteridine. See, all of them, all these important heterocyclics you need to learn and understand. So now the heterocyclic ring present in hydralazine is thalazine. Moving to the next one. Now 2,3-deoxy-5-fluorothiazide, a nucleoside reverse transcriptase inhibitor. What is this? See, the answer is emtricitabine. See, all these antiviral drugs, most of them has got nucleoside analogs. Now let us understand this structure. Thiazide, you need to understand, see, all DNA has got 4 nitrogen bases. It is always important to learn that nitrogen bases. Now this structure is cytosine. The nitrogen base cytosine is this one. Now cytidine means when cytosine is attached with the ribose sugar, it is called as cytidine. So this is what a sugar molecule is, right? Now see, understand this. 2,3-deoxy, that means at second and third position oxygen OH groups are not there. That is what is the difference between ribose and deoxyribose sugars. 2-3 position, at both the places you don't have any hydroxy groups, and 3-thia means, see, this is 1, 2, at third position you have sulfur atom is there, hence it is known as thia. Here a sulfur atom is there. So this is 3-thia, 2,3-deoxo cytidine fragment. But again it says the structure has got 5-fluoro group is there. 5-fluoro group, this is first atom 1, 2, 3, 4, and here the fluorine atom is there. This is 5th position, and here you have a fluorine atom is there. So this is what is the structure of 2,3-deoxy-5-fluoro-3-thiazide. So you need to know what all the nitrogen bases are, and then you will know what is this deoxyribose sugars, and then you need to know the places, then you will be able to write the structure. So this is related to emtricitabine. Moving to the next one. Now acidic functional group in picric acid is, now see again picric acid has got 3 nitro groups. Now see all these 3 nitro groups are very powerful electron withdrawing groups, and with a OH group is there. Because of this electron withdrawing nature, this hydrogen comes out as proton, and this acts as a very good acidic group. So what is the answer? OH. Again you can see this is a structure based question. Now deamination of 5-methyl cytosine. So just now I told you what is cytosine is. Now this is 5-methyl cytosine. In the previous case we have seen 5-fluorocytidine. Now see NH2.4. Now at 5th position you have methyl group is there. Now deamination means removal of this amine group. What happens when this amine group is removed? You will get thiamine. So again thymine is also a nitrogen base. You have this methyl group is there, right? So this is what deamination, when you remove this amine group, it results in thiamine. So this is what is the question about. What deamination of 5-methyl cytosine produces? Thiamine. Moving to the next one. Now the position of nitrogens in purine rings are, again you need to know what is a purine ring is. Again purines and pyrimidines are basic nitrogen rings present in DNA and RNA. Now this is what is a purine ring is. Now in purine ring, when you see the numbering, it starts from here 1, 2, 3, 4, 5, 6 here, 7, 8 and 9. So where do you have nitrogens? At first position, at third position, 7th position and 9th position. So what is the answer? 1, 3, 7, 9. This is the answer. Moving to the next one. Now, which crucial feature of penicillins involved in mechanism of action? See, I have explained what is a beta-lactam is. So this is called as beta-lactam. The class itself is known as beta-lactam antibiotics because this structural feature is important for its mechanism of action, and this is known as pharmacophore. Pharmacophore. The group or atoms which are responsible for the mechanism of action is known as pharmacophore. So what is that? Beta-lactam ring. Going to the next one. See the number of disulfide bonds present in insulin. See, insulin has got totally 51 amino acids are there. It has got an A chain and B chain are there. In A chain you have 21 amino acids. In B chain you have 30 amino acids are there. Now between this A and B there are 2 disulfide bonds are there. Between this A and B 2 disulfide bonds are there. But in the A you have 1 disulfide bond is there. So between is known as interdisulfide bonds. In one chain it is known as intradisulfide bonds. So totally 3 disulfide bonds are there. So the option C, 3 is correct. Now the molecular formula of cholesterol. Again you need to know the structure of cholesterol. See, all steroidal molecules are derived from this cholesterol. So it is always prudent to know the structure, to learn the structure of cholesterol. And you need to know the numbering too. Now the numbering starts from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And this one is 18, this one is 19. And here it comes 20, 21, 22, 23, 24, 25, 26, 27. Now for your knowledge, there is a double bond between 5 and 6 and a OH group at third position. That is why it is known as all, an alcohol derivative. So totally how many carbons are there? 27. So what could be the answer? C, 27 1. So again learning structures is very important. Moving to the next one. Now which is an example of steroidal antibiotic? See, fusidic acid is a steroidal antibiotic. Remember this, out of these antibiotics fusidic acid is a steroidal antibiotic. Moving to the next one. Now histamine structure is represented by, again see, it is a structure based question and you need to know what is the structure of histaminase. Now histamine is a derivative of histidine. By decarboxylation you will get histamine. Only it is amine is there, so it is histamine. Now understand what you have. You have an imidazole ring and ethylamine group is there, right? Dihydroxy, no hydroxy groups are there. Now again understand the numbering. It starts from 1, 2, 3 and at 4th position you have the substitution is there. So not the 5th position. So this is not there. And propionic acid, no acid is there. So without learning much you can easily write the answer as this one. But let us understand the name itself. So this is the answer. Now look at them. at second position in ethane an amine group is there. So first carbon, second carbon, amine is there. On first carbon, this imidazole ring is there. In the imidazole ring at fourth position, this substitution is there. That is what is this name meant by. So this is about medicinal chemistry questions. Again, I'm telling you, learning structure is very important. And you have seen it with only structures, you can do all the questions. Moving to organic chemistry questions. Now, organic chemistry questions, most of them are based on named reactions. Look at them. Identify the reaction in which acylazide is converted to isocyanate. Lawson-Schmidt, Curtius, and Wolff rearrangement. I have made a video on named rearrangements, which you will find it in GPAT playlist. Please refer to them. But to understand this, acylazide to isocyanate conversion is by Curtius rearrangement. Acylazide to isocyanate. All of them are carbon to nitrogen rearrangement. Look at this. What has happened? See, in this acid, 2 nitrogens comes out as nitrogen gas, and 1 nitrogen will be moving to second carbon. This is what happens. See nitrogen attached to second carbon. This is called as rearrangement. So acylazide to isocyanate, the rearrangement is Curtius rearrangement. So the answer is this one. Now, moving to the next one. The Wittig reaction is a chemical reaction of an aldehyde or ketone with. See, Wittig reactions are very popular to make alkenes, and they are from ylides. They react from this ylide. So the answer is A. Now, which intermediate is formed in Wolff reaction? See, Wolff reaction is with a diazo compound is converted to ketene, but the intermediate is carbene. There is an intermediate generation of carbene is there. So the option A is correct answer. Now, aniline is synthesized by, there is a process, nitrobenzene is reduced to aniline by using iron and HCl, and this process is known as Beckamp reduction. So you can see most of the organic chemistry is based on named reactions. So you need to get some mastering over named reactions. Now, identify a protophilic solvent. Let us understand that. Proto means proton, philic means like. That means the solvent which likes protons are known as protophilic solvent. Like water, alcohol, ammonia, all of them will take up a proton. So they are known as protophilic solvent. Now look at them. Carbon tetrachloride, CCl4. No, it's not protophilic. Carbon disulfide. No, it's not protophilic. Chloroform. No. No solvent can take up a proton easily. So option is none of the above. Now, which of the following is most acidic? Now, this is an interesting one. Look at this. You have comparisons between benzoic acids. So this is orthobenzoic acid, and you can say this is metabenzoic acid, and this one is parabenzoic acid. Now, out of the three, orthobenzoic acid is most acidic. The reason is when it donates a proton, what happens is this COO minus will be there, and to which this hydrogen forms a hydrogen bond. When the hydrogen bond formation is there, this ion is stabilized. When this ion is stabilized, it can easily lose a proton. Because even after losing the proton, the charge is stabilized, hence it will readily loses this proton. Hence this one is very strong acid. All the remaining one, there is no such kind of stabilization. So among all of them, the most stable anion is hydroxybenzoate anion is stable one. So it is a strong or mostly acidic one. Now, which of the following is a polar aprotic solvent? Let us understand. Polar means it should be able to generate charges. Aprotic means without protons. Now, dimethyl formamide is polar aprotic solvent. We will read about this in nucleophilic substitution reactions. Dimethyl formamide, no proton is there, but it is a polar solvent. Now, which of the following reactions are favored by polar aprotic solvents? Now, again understand this. See, SN2 is favored by polar aprotic solvents. But let us understand, what do you mean by SN2? Substitution nucleophilic bimolecular. That means nucleophile is involved and alkyl halide is involved. What happens when the alkyl halide is releasing its leaving group, a nucleophile goes and attacks here. You have a transition state, and finally you will get a final compound with inverted configuration. But understand certain things. Nucleophile need to be very active so that it will attack this carbon. Now, in order to nucleophile to be very reactive, the negative charge has to be there so that it can go and attack this carbon. But now look at this solvent. Now, because this reaction is ionic reaction, you need a polar solvent. But why aprotic solvent? If you have a proton, what happens with that? This proton will immediately goes and binds with this negative charge, and the nucleophile reacting ability goes down. So when you use a protic solvent, the reaction will not go further. So in order to increase the rate of reaction, you need to use aprotic solvent. The proton should not be there, so that nucleophile retains its reactivity, reaction goes on. So option is SN2. So in organic chemistry, you need to understand named reactions and mechanisms to answer. In medicinal chemistry, heterocyclic ring and structure is enough to give you good marks. So this is about NIPER MCQ series. If you like the video, subscribe and share. Thank you for watching this video.